What is the length, x? Label points A, B, C, D and E. Join line OE. Line O, A equals line OD, which equals to 9 units, as shown on the screen. By Pythagoras' theorem, the square of line BO equals the square of line OE minus the square of line BE, which equals the square of 9 minus the square of x. Take the square root of the equation. We have that line BO equals the square root of 81 minus the square of x. Label points F and Q. Join line C, Q. Line E, F equals line C, F which equals to line F, Q. Consider triangle CBE. By Pythagoras' theorem, the square of line CE equals the sum of 106 and 10 times the square root of 81 minus the square of x, as shown on the screen. Take the square root of the equation. It implies that line CE equals the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Divide line CE by 2. We have that half of line CE equals to half of the square root of the sum of 106 and 10 times the square root of 81 minus the square of x, which is equals to line labeled CF. Also, the result is equals to line labeled EF. Since QFC is a 45 degrees right triangle, angle cube CF equals angle C cube F which equals to 45 degrees. By Pythagoras' theorem, the square of line CQ equals the sum of the square of line CF and the square of line FQ. Substitute values and we obtained an equation for the square of line CQ, as shown on the screen. Take the square root of the equation. It follows that line CQ equals the square root of the sum of 53 and 5 times the square root of 81 minus the square of x. Consider triangle CEB. Let labeled angle ECB equals theta. By trigonometric identity, cosine theta equals the sum of 5 and the square root of 81 minus the square of x, all divided by the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Also, sin theta equals to x divided by the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Join line OQ. From triangle COQ. Use cosine rule. The square of line QO equals the sum of the square of line CQ and the square of line CO minus 2 times the product of line CQ and line CD times cosine theta plus 45 degrees. Substitute values. We obtained a new equation as shown on the screen. We call it equation 2. By trigonometric identity. Cosine theta plus 45 degrees equals the product of cosine theta and cosine 45 degrees minus the product of sine theta and sine 45 degrees. Substitute values of cosine theta and sine theta. Already, we know that sine 45 degrees equals cosine 45 degrees, which is equals to 1 divided by the square root of 2. Hence, we have that cosine theta plus 45 degrees equals the value shown on the screen. Simplify. Cosine theta plus 45 degrees equals 5 minus x plus the square root of 81 minus the square of x. All divided by the product of the square root of 2 and the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Substitute the result into equation 2. We obtained a new equation as shown on the screen. Then, simplify the right-hand side of this new equation by performing basic arithmetic and algebraic processes. We have that 81 equals the sum of 53 and 5 times the square root of 81 minus the square of x plus 25 minus in bracket, the sum of negative 5 times x and 5 times the square root of 81 minus the square of x plus 25, as shown on the screen. Open bracket, so that we can cancel equal terms with opposite signs. After simplification, we have that 81 equals the sum of 53 and 5 times x. Solve for x, divide the equation by 5. Therefore, x equals 28 divided by 5 in units or 5.6 units.